extra strong Roman concrete,
fully hydraulic,
structural welded connections,
It's the
structural
engineering podcast.
Hello, and welcome to this week's episode of the Structural Engineering Podcast. My name is Max,
I'm Zach.
and we're your hosts this evening. Today we have a very special guest, Douglas Deneu,
Hello.
and we're going to talk about some computer science and structural engineering later this episode. But first, we're going to get into a little news story that came out this week. Zach, why don't you kick us off?
Yeah, it's cold in Colorado. Back to you, Max. The news story we're going to talk this week is back into the kind of the seismic category. We seem to be hitting that a lot.
Yeah,
lately,
this falls on
something that we kind
last
of
episode.
are interested in. But so this one came out. A seismic committee was put together. ATC, I can't remember the number of the committee, but it's put together to evaluate more or less the structural resilience of high rises in California.
In San Francisco
And
specifically.
in San Francisco. So, yeah.
And they looked at 156 high rises greater than 240 stories.
Mm-hmm.
And they're trying to put together a 30-year earthquake safety implementation program to kind of protect the city, increase the resilience for the pending earthquakes. This article mentions that the USGS estimates a 72% chance of a magnitude 6.7 earthquake or greater before 2043.
Yeah.
Which is some interesting statistics that is very specific.
Yeah, absolutely.
That's how this works.
And I think like the big thing with articles and what the committee was trying to do is how do you evaluate buildings not just for it works through the
Well, for
earthquake, but
life
how
safety,
to continue the life of the building through an earthquake and look at the economics of what that building is doing for the city through that earthquake. Sure, a 2-story building collapses or is not usable anymore and you have to tear it down, build a new one, has a less effect than your 240 plus story building on the economy of that city. So.
Yeah, and they're also targeting now something called functional recovery, which goes beyond life safety. So many seismic designs are targeted for life safety, so the building won't collapse, but it may not be usable any longer.
Right.
And then if you get into hospital, you may have immediate occupancy buildings. But like you were saying, this functional recovery allows the city to kind of protect what brings people there. They mentioned travel, just keeping the city as a tourist destination.
Yeah.
There's a lot of things that add to the economic value, and if a bunch of cities or a bunch of buildings aren't occupiable, that value decreases.
Yeah, I think it's interesting. Like performance-based design up to this point, it was based off of the like what the owner wanted to do. And now the city's kind of trying to drive that.
Mm-hmm.
So I think it's pretty interesting. You're taking a public entity and you're trying to mix that with a private developer, So you're trying to push them even more onto doing something different. And I think a lot of that performance-based design was initially based off of insurance policies.
Mm-hmm.
And so I think that would probably increase, or not increase, but help like with your insurance policy potentially on a high rise. So
something else I thought was pretty cool in this is they were talking about 1989 Loma Prieta, and that they can using this new series of this code series, they can go back and evaluate buildings that were built before Loma Prieta and decide after the fact which ones may need additional inspection. And they were saying that by doing a history analysis of the actual frequencies that occurred during that event, go back, build models of these things, shake them, and figure out which buildings need more inspection. And the estimate was only 10 to 15% of welds may need inspected. But apparently Loma Prieta was pretty low amplitude earthquake.
Yeah, I think it'll be interesting to see. Many cities have done something similar to this, maybe not seismically or for tall structures, but have tried to push these sorts of things onto building owners. And I think it'll be interesting to see who has to pay for it in the end.
Yeah.
Right? I mean, the city's saying you have to, and these buildings need to be analyzed, but who's going to pay to analyze them?
The other thing, I have a correction from one of our older ones. We said that Northridge was 1989. Loma Prieta was 1989.
Oh.
Northridge is 1994.
Yeah, that's close.
Yeah, we're pretty good. I mean, good enough.
Well, we're very factual here. So.
We catch it eventually. We'll catch it when it comes around.
Yeah.
I think that's pretty much all the news. Do you have anything else from that one?
Still cold in Colorado?
Still cold in Colorado.
Yeah.
Wraps it up.
Yeah, so let's jump into this.
All right. So, our guest, Doug, let's do a little background. What do you do?
Yeah.
What's your social security number, credit card?
Yeah.
Whatever you want to tell us.
I'm a software engineer.
Nice.
And so I went to school for computer science. Have a master's in computer science, which I just completed.
All right.
And so I spent a little time out and about, a little bit in California in the Bay Area. So hopefully those buildings are
stay in the
up
shorter
now.
buildings.
Yeah, that's right.
Good. Yeah.
And so did some work out there for a little while. Some in Colorado, some contracting, some for nonprofit. Kind of bounced around a bit.
Cool. Well, hopefully we have some software questions for you and some hardware that are reasonably intelligent. This is something I've been interested in getting into recently, programming in general and learning a little bit more about computers. I've had like a couple people ask me if I've talked about this, and I kind of have basically what feels like a canned answer at this point, but see what you think. It's like the reason I'm sort of trying to learn some programming myself is that I think a higher computer literacy will be much more important, in the coming years, and maybe 10 years from now, as you have kids that are learning programming like at a very young age, right? A lot of these like middle schools are getting into it. You might start to see more of that, like kind of in all fields.
Yeah, I think definitely even when I was in high school, it's something that I missed out on, and it's something that's really rapidly progressed now. Where I went to school in very rural Vermont, they have programs now for programming and computer science style of classes, and almost in any field, especially the STEM fields you get into, you're going to have a lot of folks taking one or two side classes in college or something for programming to kind of go along with their other discipline,
which is awesome. So I feel like we just missed the wave of people that will
never
know
too
how
late
to do all this. That's right, back to school again. Why not? Sweet. Yeah. So as I mentioned, I'm kind of trying to learn programming. We talked about this a little bit, but one of the languages that I kind of have gotten into is something called Python. From what I understand, that is high level, which means easy, right? So like more or less,
right?
Like,
more extracted from the computer hardware.
Yep. Oh, got it. Okay, so
less ones and zeros, more English.
I haven't typed a 1 or 0 yet.
Perfect.
Nice. I'm doing it good. What would you recommend? So, say you didn't have any computer programming in school, and it's something you kind of want to try, and maybe on the bent of you want to get into maybe developing little applications for yourself to use, in your firm. If you want to do something outside of Excel, which is what we would typically use,
right?
Like, what would you recommend language-wise?
I think Python is a great place to start.
Yes.
So it's a relatively
thank goodness.
It's a relatively new language.
I feel like you guys worked that one out before you got here.
Yeah,
he works for Python.
But even when I was in undergrad, what I first started was you kind of start in C++, which is kind of a more robust, closer to the computer kind of language. So usually there's a lot more syntax that's involved, a lot more places to go wrong. It's a little bit more convoluted and complex. And by the time I was heading out, they had switched over to do all intro classes to Python.
Really?
Yep. And that was for a couple reasons. One, I think it helps engage first-timers into computer science a bit more, because you can do a little more fun programs like moving turtles around or a little game.
That'd be really applicable at our office.
Tic-tac-toe and Pong and all those good things that if you were to do in C++ would be just hundreds and hundreds of lines of code.
Whoa, okay.
Where in Python maybe it'd be 30 or something.
Who developed Python?
Oh, boy.
Is it like a Google thing?
Yeah.
I think
I feel ashamed. I feel ashamed for not knowing.
Okay.
For all those computer science nerds out there, that I'm going to let them down. I don't remember.
Do you know when it was developed at all?
That's another good question.
Was that one 2007? Fortran.
Okay.
Oh yeah,
No.
But then I was like, well, that's not.
Yeah.
You explained me wrong.
Okay.
Yeah.
Interesting.
I'm just here
Who
to ask
knows?
hard questions.
Yeah.
Those are the stumpers.
Yeah, really.
Historical computer science. Yeah, that's what I need to focus on next.
Yeah,
For sure.
Yeah. Follow-up podcast.
I think there's
we'll
a
go
lot of
through
room in
these.
the field of historical computer scientists.
Yeah.
So-
There's a great museum out in San Jose.
Really?
Yeah.
Oh, cool.
Yeah.
Fun to see.
It is pretty cool.
So on that programming, do you sort of agree? Like, so Excel is great for basically everything we do when we have to make some sort of repeated calculator, like a fake program, whatever you want to call it. And we're not talking even using VBA here. This is just like many, many linked cells that may be grabbed from a table and interpolate.
Right.
Not complicated, but there's a lot of downsides to Excel. Like, you can't tell what's going on at all. Every cell is hidden. It's like cryptic, right? You look at like a bunch of dollar signs and numbers, and you have to trace this line. Do you think that Excel will move toward, like, have a version? I don't know. Do you think there's gonna be some changes? Or do you think people will start using other, like Excel will stay Excel and
I think one of the nice kind of side benefits of writing your own tool or script for whatever you're doing, whether it be in Python or something else, is usually these things are developed in a shared repository. And so things like Bitbucket or GitHub, where you're doing revision control on your work. And so you might write something and save it, and that's going to go up to a cloud or other shared service where other people can see what you're pushing and working on. It also forces you to kind of document what you're doing, kind of line by line. So it's kind of self-documenting your code, and it's also distributing it to other folks in your office, or a little group, or privately. And so I think it has a lot of advantages of kind of being able to go in there. If you were going to go look at some of Zach's stuff that he's did and kind of see his train of thought and look at his comments and be able to read through it and make kind of logical sense.
Yeah, it's a little more transferable or understandable if you just pick up someone's, from where they left off. Might be easier to figure out what's going on if they document well.
Yeah.
That's what was hard. You said GitHub is a repository. What is? You define that.
Yeah, sure. So
we're a dull crowd.
Absolutely. So
I've used GitHub.
Have you?
Yeah.
Oh my gosh.
A lot of like 3D printing stuff is on there.
Huh.
A lot of people
great.
do changes on the firmware and stuff.
So it's just like an online library of
it's like a
codes
website.
in progress.
So basically what happens is, like, if you have a website like GitHub and they have their servers space, and so if you're on your local machine and you're doing work and then you save your changes, what you basically do is you push those up to GitHub, so your GitHub account, and that's going to create like a unique hash. And so it's like those changes have a specific tag, so later if you're like, oh, that introduced a bug, like whatever I did there caused something else to fail, everything is marked. So you can kind of think of like all the new rage now is with like Bitcoin and all that fancy stuff is the kind of, you get your list of exchanges that have happened, and supposedly you can't alter those, and those are transparent things. And that's basically what revision control does. So you could go back and be like, oh, update my code to this previous change that I made, and it'll bring everything back.
Cool.
Yeah. So it's a great way of history tracking everything that you've done.
That's sweet. Let's say beyond Python, if there even needs to be, if someone was really getting into it, is there like, could you do some more complex stuff? It seems like Python is pretty capable. Would there be a next step, or like you think that's probably adequate? Like if you get good at Python,
I think
good.
Python's a great place for starting with scripts and doing some entry stuff for sure. It could kind of go in two directions from that, as far as I think about it, is if you wanted working with stuff that was like, hey, this has got to run fast, like this needs to be written in such a way where like failures are low, everything is, we have control of a lot of what's going on, then you kind of go towards like C++ and Java, and they're just more strongly formatted languages where it forces you to write it in such a way where you'll have less mistakes.
Okay.
And so one instance of that is in Python, kind of how variables work is they're dynamic. So you don't have to explicitly say if you want to use an integer or a floating point number or a string. The kind of compiler in Python is going to take care of that for you. But in C++ or Java, it makes you type that out while you're writing your program. So if you're writing a function that expects an integer, it better get an integer. Otherwise, it won't continue on, whereas Python will try to negotiate and do some on-the-fly stuff for you. That might introduce some bugs. Yeah.
Interesting.
And then likewise, you could go to the web development route.
Yeah.
If you're more interested in kind of graphical websites that folks can go on from anywhere and click around, you could go to JavaScript. Would be the logical choice there, I think. Yeah.
Cool. What do you say about the programs that we probably use now? We gave you a quick rundown on like what's sort of common, but we'll say like we use RISA, Anarcalc, RAM, our fingers and toes. What other software do we use? Is that everything?
I think that's like the big thing.
Yeah, those are the big guys.
Yeah. So I try to do a little homework on this,
Nice.
and not knowing much about the structural engineering software game.
They don't have a specific course on that?
No, we didn't run into that.
You're not starting a business after your research?
No, it looks too complicated for me. But I think what a lot of these are probably written in a lower level language like C or C++. I think specifically I was looking at programs like AutoCAD or this other one that was from that, but I can't remember. Perhaps. And they were really low level C, C++, and then a language called Lisp, which is a functional programming language. Yeah, that's getting in the weeds a little bit. Just things that are closer to the hardware. So more assembly close language, which means you're getting in there and specifying kind of your memory and disk space allocation.
Allotted,
where it's much more hands-on at the hardware level. So,
but probably faster, right?
Faster, more probably better tested for reliability. Whereas like Silicon Valley, you're working on an app, you're doing something for Snapchat or whatever. Failure is not that crucial. But if you're doing calculations for structural engineering or if you're NASA or you're working on cars or something that there has to be a reliability component, you're going to be probably working with languages that are much more closer to the hardware.
That's super interesting.
Yeah.
I'm blown away.
Yeah.
We just see it as a big black box.
Yeah.
And it's just doing its thing.
Yeah, I will say that trying to find some information on the development of these tools, it's difficult to get at anything. It's definitely proprietary stuff. So
I bet.
Now, this is a really stupid question, but if you saw the software, could you figure out what it was written in?
What it was written in, yeah.
Okay.
What it was doing.
That's a totally different question.
What are like the tells? How would you know?
Syntax.
Oh.
Yeah, so each language will have a very unique kind of way it goes about syntax, with anything from like curly braces being used to how they set up a function call or
Okay.
Yeah.
Sweet.
Okay, so the other thing.
Yeah.
So, like finite element analysis is like super tacked in on the computer, and the program will like you can go into the settings and it'll ask you like how many cores on your processor to use and like should I wreck your computer or whatnot. But how much experience with that type of programming that's super, I guess like what we hardware heavy.
Yeah.
Like, do you have have you programmed a lot of things where like it's using crazy computers and
my job I had in California was doing GIS software, and so oftentimes having these map data sets of anywhere from a gig to 16 gigs and trying to crunch numbers on those, and so we definitely had to think about memory management.
So that's it within your coding.
Yeah, okay. Absolutely. You definitely can be there are definitely instances where you can't cut corners just because the program might take too long if you really try to be memory efficient.
Yeah.
But there is probably a large swath of laziness where it's like, oh, you need to have 8 gigs of RAM or something to run this. And maybe you do, or maybe they just didn't want to really get into those algorithms. But for instance, one thing that we had to focus on was we were doing a lot of work with folks in other countries like South America, where internet access and computers probably weren't going to be necessarily, they're not going to have access to a really good supercomputer or anything like that. So we had to be really memory kind of conscious and going through and saying like, okay, we can't get over 2 gigs, kind of eyeing things to make sure the chunks of map that we're operating on were done in such a way where there was never too big of anything being loaded at once.
And that's sort of your RAM that you're calling here, like that little pocket of memory.
So,
right.
Yeah.
RAM, yep, is what I'm referring to.
Yeah, so I ran a finite element analysis, and it tacked the computer for 45 minutes, 100% CPU, 100% memory.
4 cores.
Yeah. So what would I need to do to have that
Yeah, make it better.
Speed up. Now, we have access to, like we were talking earlier, to a server that could probably do it really fast. But the computer I have, what else do I need to do? What do you like? I'm kind of
if you're not able to a little bit, it kind of sucks because in some it's hard to know without knowing what's going on and how they're writing their stuff, but it could be that when they ask those questions, they are saying, okay, this is the resources I have to use this technique in order to run this.
Okay.
And it might be trying to be memory efficient, but taking exponentially longer for that.
So in the settings I went in, I told it to use everything.
Right.
So I was trying to like speed it up, but 45 minutes.
Yeah. Yeah, that's a tough one. Yeah.
So maybe using external servers is probably the way to go if you want to do this higher computing and don't necessarily have the best computer for it.
Yeah.
Are there any online resources? Can you
cloud-based
cloud a server?
I know there is one of our softwares does do that. You can upload your model and they do iterate solutions for you, and they they'll track all the code stuff and it come to a point and they're like, okay, we can't change much after this. Here's your model back.
Right.
And it was fairly cheap. I think it was very inexpensive. It was $45 to do your whole model.
Yeah.
So and that was all using their
that's pretty nice
servers. So might be a better option.
Yeah, I'm not sure how it'd be going to Amazon Web Services with just the individual person, if that'd be cost effective or not.
Yeah. Okay. So that stuff could
my
be. My
brother-in-law works for him. I'll ask.
Perfect.
Yeah, there you
get
go.
us in.
Yeah. We had a similar thing where there's a GIS program called ArcGIS, which is
I used that in college.
Yeah, very proprietary. Got to pay for a license.
It crashed all the time. I really didn't like it.
Yeah, there you go. So we were initially, our company was using that in order to write their models in and distribute it, but they were touting themselves as an open source project. But you needed ArcGIS to run it, which was a proprietary license to pay for. So that was tough. And like you mentioned, oftentimes you'd get crashes for no reason with very little response. And so it's kind of when we decided to pull everything out of there and write our own standalone version that hopefully was better. Yeah.
Wow.
Sounds like a big investment.
Yeah. That's the long-term investment. Yeah. I think it paid off, though, for the project, for sure.
Cool.
Definitely.
Huh.
You got any more computer structure questions?
Oh.
Getting to about 20 minutes. Well, let's shut it down. Thank you, Doug, for joining us.
Yeah, thanks for having me.
It was a pleasure.
If you guys have any questions for him, let us know.
Yeah, we can chase them down. So send questions. Show Notes has an email. You can find us on Facebook or Instagram or YouTube.
We're on the internet.
Just about anywhere you look.
Yeah.
All right. Bye-bye.
Bye.